Hi there and welcome to another video from Hegarty Maths. It's Mr. Hegarty here and it's the 30th video, so a big project so far on the GCSE Maths Higher Revision. This topic is going to be on similar shapes. Now just to remind you how these videos work, I can't teach you it all in this video. This video is for revision purposes. You watch the start of the video, you take every single piece of the notes down that I do at the start in the first few examples, then I'll tell you when to pause and you try every exam question that has come up on this topic. You can print out the worksheets from hegartymaths.com in the Secure CB section. Okay, let's start. Similar shapes we're going to talk about today. And firstly, we're going to quickly discuss what does similar mean in maths. When you see this word, and it will come up in questions, it's come up 4 or 5 times in the past GCSE questions, you know to use what I'm about to teach you. Anyway, similar means two shapes are similar, so two shapes are similar if one is an enlargement of the other. If one is an enlargement of another. Okay, for example, just very quickly, let's just get two rectangles, like say like that one there. Okay, and I'm just going to copy this one. I'm just going to make it bigger. That shape's an enlargement of that shape and they're similar. So say if I told you that this length here was 4 centimeters and I told you that this length here was 8 centimeters, you would know that this shape must be double this shape. Okay, it's double that shape. Okay, what type of questions come up? Well, basically they ask you to work out missing lengths, areas, or volumes, okay, when they talk about similar shapes. And the last one they come up in worded questions, okay, and we're going to see an example of these in the exam paper questions. Right, let's do 2 examples to show you how these things work. So imagine we are told the following shapes are mathematically similar. You highlight that word. This is a topic about similar shapes. And we're asked various questions. Now, before we even go into the questions, I always want you to do the following things. I want you to go over here and to work out 3 things. What's called the length scale factor, LSF, the area scale factor, ASF, and the volume scale factor, VSF, before you even start the question. Now, how do you work out the length scale factor? Well, the length scale factor is if you can find a side on the big shape and the equivalent side on the small shape and you divide them, that tells you how much bigger one shape is than the other. Now, we have this length, but we don't have this length here, so we can't use them. We don't have this length nor this length, so we can't use those sides. We don't have this length, even though we have this length. But look, we have this EH, this side here is 3, and we have the equivalent side on the big shape is 12. So using those, we can work out the length scale factor. And the length scale factor is the big one divided by the small one, 12 divided by 3, which is 4. So what that's telling me is it's telling me the lengths in this shape are 4 times bigger than the lengths in this shape. If I have a length here, I can times it by 4 to get a length here. If I have a length here, I can divide it by 4 to get the small length. Now, this stood for length, this stood for area, this stood for volume. Just like in length, usually the units are centimeters. In area, the units are centimeters squared, so you square centimeters, and in volume, the units are centimeters cubed. Once you have the length scale factor, you can get the area scale factor and the volume scale factor by area scale factor is this number squared, so 4 squared, which is equal to 16. And the volume scale factor is the original 4 cubed. And 4 cubed, using your calculator, so we can just type in 4 to the power of 3 is equal to 64. Now we've got every single piece of information we need to answer these style of questions. Right, it says calculate the length of BC. BC is this one. Let's identify the similar side on the small shape, this one, which is given. That's 5. How do you get from from the small shape to the big shape? You must multiply, and we're going to use the length scale factor because we're dealing with lengths. So BC, the length of BC, must be equal to the length of the small shape 5 multiplied by the length scale factor, which is 4. So it's going to be equal to 20. And write the unit centimeters. Okay, the next one, the length of EF. So EF, let's identify EF. Oh, it's on the small shape. Do we have the one on the big shape? We do, it's 7.5. So how do we go from big to small? We divide. So to get EF, the length of EF must be the big side, 7.5, this time divided by the length scale factor of 4. So what we do is get the calculator out, 7.5 divided by 4, and we get ourselves 1.875. So the answer is 1.875 and centimeters again. Okay, now we're asked about the area. It says that the area of the big shape is 320. Work out the area of the small shape. So we're going from big to small. So we're going to divide. This time not by the length scale factor. This time by the area scale factor because we're dealing with area. So we're going from big to small, so we're going to do 320 divided by the area scale factor, which is 16. 320 divided by 16 is 20. So this time the answer is 20, and because it's area, the unit's centimeters squared. And lastly, we're asked this time about the volume. So obviously we're going to use the volume scale factor, right? We're given the volume of the small is 500. We're asked for the volume of the big. To go from small to big, you multiply. So we're going to take the 500 and we're going to multiply it by the volume scale factor, which is 64. So calculate it out. 500 multiplied by 64 is equal to 32,000. Again, make sure we get the units right. Because it's volume, it's centimeters cubed. Okay, and there's the first example. So we're going to try one more, very similar to this, just so I can show you something quite important with the length scale factor. So we're going to do one more just like this together. Okay, so it says that the shapes again are mathematically similar. I told you that what you must do straight away is go over, work out the length scale factor, the area scale factor, and the volume scale factor. That's the first thing you do before you even work through the question. Okay, now you look at the two shapes, you see where you see a side that's equivalent on both. Here is the only place where we've got the side on the big shape and we've got the side on the small shape. So the length scale factor is going to equal 14 divided by 3. Now if we go to our calculator and do 14 divided by 3 and press SD, it's this long not a decimal that doesn't stop. In that case, I don't want you to write 4.6 as the length scale factor. If you round it or write 4.7, you will get the answer wrong. You must leave it, therefore, in fraction form. So we're going to leave it as 14 over 3. And we just got to be a bit more careful typing in our calculator. What's the area scale factor going to be? Well, the area scale factor is going to be 14 over 3, press equals, and square it. 196 over 9, so it's going to be 196 divided by 9. What's the volume scale factor going to be? Well, again, it's 14 divided by 3, like that, and then to the power of 3. 2744 over 27, so 2744 divided by 27. Okay, it's really important that you leave it like that. Now, one thing I want to point out, if you have 14 over 3 like this, and you press to the power, the squared there, it comes out correct. But just say when you're typing in your calculator, if you put that square just on the top, say if you put it here with the 14, it won't come out right. You've got to do 14 over 3 equals and then square it to get your right answer, okay? So they're all our scale factors. Let's get ready to do this question. We want to work out the length AD. We've got the small length, which is EH. To go from small to big, you multiply. Because we're dealing with lengths, we're going to multiply by the length scale factor. So we're going to do 1.5 multiplied by 14 over 3. Calculator out. 1.5 multiplied by fraction 14 over 3. We get 7. So it's 7 centimetres. Now we want the length of EF. Well, EF's the small one, and we've got the length, the equivalent length here. So what we're going to do is we're going to divide. So we're going to take 7 this time and divide it by the length scale factor, fraction 14 over 3. And we get the answer 1.5. And the unit is 1.5 centimetres. I did a big mistake here and didn't show my working. You must show your working. Each of these are 2 marks. So to get EF, we did 7 divided by 14 over 3. Now we're dealing with area. The area of the big shape is 140 centimetres squared. What's the area of the small? To go from big to small, we divide. So we're going to do 140 divided by the area scale factor, which is 196 over 9. So if we do that here, we're going to do 140 divided by fraction 196 over 9, and we're going to get ourselves the answer 6.428. At this point, they will ask you to round, let's say round to 1 decimal place. At this point, you could say 6.4 centimetres squared to 1 decimal place. Now the last one is a volume question. They've got the volume of the small. You want to get the volume of the big, so we're going to multiply. The volume of the small is 2,100. We're going to multiply it by the volume scale factor, 2744 over 27. So 2,100 multiplied by 2744 over 27. And we get the answer 213422. Let's just leave it like that. 213422. Okay, and centimeters cubed. And that's how you do these questions. Don't round your length scale factor, area scale factor, and volume scale factor. Leave them as fractions, but you could do your rounding at the end. Right, this is the time to pause the video. Pause the video, and if you've printed out the worksheets, work through the exam questions. After, in 5 minutes, I'm going to go through the answers. Here's the first one. So 5 seconds, I'll go through. Okay, so we are told that these shapes are similar, and straight away we go over here and work out our length scale factor, our area scale factor. We don't need volume actually here because it's not a 3D shape, so we're not going to need volume here. Okay, you could work out your volume scale factor, but it's not necessary. So length scale factor, we have the 6 here and the 4 here. So the length scale factor is 6 divided by 4, and if you get your calculator and do that, 6 divided by 4, you get yourself 1.5. So it's 1.5. Therefore, the area scale factor is 1.5 squared. So 1.5 squared, which is 2.25. You don't need the volume scale factor, but obviously it would be 1.5 cubed. But we're not going to need it in this question. There's no volume asked. We're asked to work out the length of DF. That's the big one. We're going from small to big, so we're going to multiply, and we're going to multiply by 1.5. So to get DF, DF is going to equal 9 multiplied by 1.5. Calculator out, 9 multiplied by 1.5, we get ourselves 13.5 centimetres. Then it says work out the length BC. BC is on the small shape, and we've got the big one. So to go from big to small, we divide. So BC must be the 10.5 we're given, divided by the length scale factor of 1.5. So if we get our calculator, 10.5 divided by 1.5, we get ourselves 7 centimetres. 2 marks for each of these usually. Okay, the last one's asking us about area. We're obviously going to use the area scale factor. We're given the small, we're asked the big, so we're multiplying. So we do 36 multiplied by 2.25. So 36 multiplied by 2.25 is 81. Remember to get the units right, 81 centimetres squared. And we're done. Okay, next exam style question. Pause the video. In 5 seconds I go through. Okay, very similar here. It should have said, actually, I cut out a bit where it said they were similar shapes. Okay, I cut that by mistake. They were similar. And what we're going to do is we're going to go off here and work out the length scale factor and the area scale factor. We're not needing volume because it's a flat shape. It has no volume and it's not asked for in the question. So the length scale factor, we've got the 10 and we've got the 6. So we're going to do 10 divided by 6. Get your calculator out. 10 divided by 6, and it gives us a going on decimal. So we're going to leave it as 5/3, right? And the area scale factor, well, we know it's 5/3, so 5 divided by 3 plus equals, then we're going to square it. It's 25/9, so 25/9. So we're asked to work out the length of BC. BC is on the big shape. So we're going from small to big. Notice how they put the bigger one first just to confuse you. We're going from small to big, so we're multiplying by the length scale factor 5/3. So 12 multiplied by 5/3, calculator out, 12 multiplied by 5/3 equals 20. Let's get the unit right. It's length, so it's centimetres. The length of PR now, well, PR's on the small one and we've got the big one. So going from big to small, we divide. So we're going to do 18 divided by the length scale factor 5/3. 18 divided by 5/3, and we get ourselves the answer 10.8. So 10.8 centimetres. Lastly, they say the area of the big shape is 50. Work out the area of the small. Big to small we divide. So we're going to do 50 divide by what? The area scale factor 25/9. So calculator out, 50 divided by 25/9, and we get ourselves 18. 18 what? Centimetres squared. Okay, next question. Pause the video. I'll go through in 5 seconds. Okay, this question was slightly different. It didn't give you the two pictures. It gave you all the details in some text. It said a company makes small monsters. Everything was small. I'm going to highlight in yellow. Small monsters, height of 20. A small monster has an area of 300. The company also makes large monsters, different color, height of 120. Small monsters, it says, and the large monsters are, here's the keyword, mathematically similar. Work out the area, the surface area of the large monster. What I would do if I was you is I'd draw a little picture just to represent this. Forget their picture. Let's draw a small monster. Let's draw a large monster. We're told from the question that the height of the small monster is 20 centimeters. And we're also told it's got an area of 300 centimeters squared. Okay, what else are we told? The large monsters have a height of 120 centimeters. And we're asked, actually, what is the area? That's the thing we want to find. Okay, so these are our small monsters. These are our large monsters. And they're similar. So the first thing we're going to do is we're going to obviously go over here and work out our length scale factor and our area scale factor. Our length scale factor must be 120 divided by 20. 120 divided by 20. Calculator out. 120 divided by 20 is equal to 6. So that's 6. Area scale factor is always length scale factor squared. So we do 6 squared is 36. So we should have everything we need now. We're asked what's the area of the large one. Well, we've got the area of the small one. To go from small to large, we multiply, and we're going to multiply by area scale factor. So we're going to do 300 multiplied by 36. 300 multiplied by 36, 10,800. Let's get the units right. Because it's area, centimeters squared. So we write here 10,800, and we're done. Okay, another question. Off you go. Have a go. 5 seconds, I'll go through. Okay, again, we are told that we've got two similar solids. We've got solid A and we've got solid B. It says solid A has a volume of 80 centimeters cubed. Work out the volume of solid B. We know the length. A length in solid A is 4, and we want to work out the length and the length of solid B is 8. So before we start the question, let's go over here, work out our length scale factor. This time we're going to need our area scale factor and volume scale factor. It's a 3D shape. So length scale factor is 8 divided by 4. 8 divided by 4 is 2. Area scale factor must be 2 squared, which is 4. Volume scale factor must be the 2 again, but cubed. 2 cubed is 2 times 2 times 2, which is 8. There we go, all the key information we need to deal with this question. We're asked to work out the volume of solid B, the big one. We've got the volume of the small one. We're going from small to big, so we multiply. So we take that 80, we multiply it by the volume scale factor of 8. 80 multiplied by 8, you can get your calculator out, it'll always be a calculator paper. 80 multiplied by 8 is equal to 640 centimeters cubed. The next one, the solid has a surface area of 160. So the big one has an area of 160, work out the area of the small. From big to small, we divide. So we take our 160, we're going to divide, but this time by the area scale factor because we're dealing with area. So we're going to divide by 4, and if we get our calculator, 160 divided by 4 is equal to 40 centimeters squared. Okay, the last question for you guys to try. Pause the video, I'll go through in 5 seconds. Okay, it says shapes P and Q are two triangular prisms and they are mathematically similar. It says that P, here's all the information about P. P has a length of 6, an area of 10 centimeters squared, and a length back here of 15. Q has a length of 12. We don't know the area, okay? But it tells us here that it tells us all the information that's on the picture here. But it asks us to work out the volume of prism Q. Before you do that, go over here and work out your length scale factor, your area scale factor, and your volume scale factor, because we're going to need up to volume. Length scale factor is 12 divided by the 6. 12 divided by 6 is 2. Area scale factor is 2 squared, which is 4. Volume scale factor is 2 cubed, which is 2 multiplied by 2 multiplied by 2, which is 8. Here's the key information we're going to need. Now, we know to get the volume of the big one, so the volume I'm going to write of Q must be the VSF, the volume scale factor, multiplied by the volume of P. Now, we don't actually know the volume of P, but we can work out the volume of P because it's a prism. You should know that in your formula booklet it has a picture like this, and it says you can work out the volume of a prism by multiplying the area of the face by the height back. So here we've got the area of the face, which is 10. We can multiply it by the 15, so it's 150 centimeters cubed. So what's the volume of the big one? Well, it's the volume scale factor, which is 8 multiplied by 150, and 8 multiplied by 150 is equal to 1,200. Let's get the unit right. It's obviously centimeters cubed, and we're done. So this was a slightly harder question because you actually had to work out the volume of this prism. That was one of my earlier videos, so if you're unsure, so go back and watch that. So thanks for watching. Hope you found that really useful.